So this machine doesn't really introduce itself with flashy design choices or gimmicks. It kind of just sits there, solid and serious, like it already knows exactly what it's meant to do. This is a high-end mobile workstation built around one clear idea: sustained performance under real professional workloads. Not short bursts. Not benchmark tricks. Actual heavy-duty work like engineering simulations, architectural modeling, 3D rendering, and large-scale creative production. Inside, it's powered by an Intel Core i7-14700HX processor, paired with 64GB of DDR5 memory and a 1TB SSD. That combination alone already puts it in desktop replacement territory. But what really defines the experience is the NVIDIA RTX 3500 Ada GPU with 12GB of VRAM. This is not a consumer gaming GPU repurposed for productivity. It's a professional graphics solution designed specifically for precision workloads like CAD, DCC applications, and GPU-accelerated rendering engines. When you actually start pushing it, the difference becomes clear. Heavy 3D scenes don't immediately slow it down. Large assemblies in engineering software remain responsive. Timeline scrubbing in professional video editing workflows stays smooth even when effects stack up. It's the kind of system where performance degradation is less about sudden drops and more about gradual scaling depending on how far you push it. The display is a 16-inch 4K plus UHD plus panel, and this is where detail-oriented work really benefits. Sharpness is immediately noticeable, especially when dealing with fine geometry, text-heavy blueprints, or color-sensitive creative work. It's not just about resolution either. It's about clarity, consistency, and how much trust you can place in what you're seeing when precision matters. Thermal design is built around stability rather than silence at all costs. Under light workloads, it stays relatively controlled. But under sustained rendering or simulation loads, the cooling system ramps up in a predictable way to maintain consistent performance. The goal here isn't to avoid heat entirely, it's to manage it without throttling the system into instability. Memory capacity at 64GB changes the entire multitasking equation. Instead of constantly optimizing what stays open, workflows become more fluid. Large project files, multiple design applications, background rendering tasks, and research tools can all run simultaneously without forcing constant compromise. This is where workstation-class hardware starts to justify itself. The keyboard experience follows a very specific philosophy. It's built for long-form productivity rather than casual use. Key travel is deliberate, feedback is tactile, and the layout prioritizes efficiency. It's the kind of input system designed for people who spend hours typing code, documentation, or commands rather than occasional browsing. Build quality continues the same theme. It's not focused on being thin or visually aggressive. Instead, it leans into durability, rigidity, and long-term reliability. The chassis feels engineered to handle transport, desk setups, and continuous use cycles without feeling fragile or overly delicate. Battery life, realistically, depends heavily on workload. Light productivity tasks can stretch it further, but sustained GPU or CPU-heavy work shifts it quickly into a plugged-in performance mode scenario. That's expected for this category, where power delivery is prioritized over extended, unplugged runtime. What stands out most about a system like this is not any single spec, but how consistently all components work together under pressure. The processor doesn't feel bottlenecked by memory. The GPU isn't starved of data. The storage keeps up with large file operations. Everything is tuned for stability during demanding workloads rather than short performance spikes. This type of machine isn't aimed at general users. It's not positioned for casual productivity or entertainment-focused computing. It exists for workflows where failure isn't an option and time efficiency directly impacts output quality and deadlines. For engineering environments, architectural studios, industrial design workflows, and professional content creation pipelines, this level of hardware starts to make sense. It reduces friction in the process. It removes waiting periods that normally slow down iteration cycles. And it allows projects to scale without immediately hitting hardware limitations. At the same time, it's important to recognize what it is not. It is not optimized for portability in the ultralight sense. It is not designed to be silent under load. And it is not meant to compete with thin and light laptops on convenience. Instead, it focuses on a different kind of portability, bringing workstation-class capability away from a fixed desktop environment without sacrificing core performance. In practical terms, that means you're trading convenience for capability. But in professional environments, that trade often makes sense when deadlines, performance, and reliability matter more than minimal weight or extended battery life. This is ultimately a machine built for a very specific kind of user. Someone who values predictable performance under pressure, who works with heavy computational or graphical workloads, and who needs a system that behaves consistently across long, demanding sessions. It doesn't try to redefine what a laptop is. It simply pushes what a mobile workstation can realistically handle today. And for the people who actually need that level of power, it doesn't feel excessive. It feels necessary.